Welcome students into the series of lectures on LangGraph. And in the series of lectures of LangGraph, in the last two sessions, we focused on understanding the critical components of LangGraph. And we also learned about how to implement the LangGraph workflow. So in the last session, we discussed about the nodes, the implementation of the nodes. We discussed about the implementation of the edges and also how we will implement the state. Now, in this session, we'll go through a Jupyter Notebook, as in the Python code, and try to run it, try to see that whether the understanding that we built in the last two sessions is it actually working, and what is the right way to implement the base level code for LangGraph. See, understand we are not using VS Code, or we are not like trying to just create the environment and everything, because I just want to keep this lecture very simple and straightforward, because I want you to understand the basic level implementation of LangGraph. So I'm keeping it very simple at the base level. And if you're able to implement and understand this code, then you're good to start implementing LangGraph in your firm, in your processes that you run. Okay. So the first step that you see on the screen is importing the requisite library. So in any coding exercise, what we need to do, we need to import the requisite library. What are the requisite library that we have? We are importing the typing and LangGraph, and in typing we are importing actually TypedDict, and from LangGraph we are importing StateGraph, start and end. Now TypedDict is a very special kind of uh, class inside the typing library. Why we are using it? We are using it to define our dictionary. For what? For our state. Why we are using it? Because it gives you a predefined keys and predefined data types for the values of the keys. Okay. Now, why we are importing state graph? Because if you do not import state graph, you cannot implement the workflow, because in the land graph, state graph is the class which understand the nodes, which understand the edges, which understand the state, and it also helps to combine the nodes, the edges, and the states. You also see start and end. Yes, there is a minor connection. I stated it like a class in the last session, but it is not actually a class. It is a kind of a marker. It is a kind of a constant which tells your workflow what is the entry and the exit point. That's it. So once you have imported all this, I'm running it for you. Now you can start defining your state. So I'm defining my state. See, I'm defining my state. What I'm doing while I'm defining the state, the first thing I'm doing is I'm trying to inherit a class which is TypedDict, which I imported from typing. Why? Because I want to create a structured dictionary. For what? For my state. You can simply create a dictionary, but the problem with that dictionary would be that it won't have a predefined data type. By using TypedDict, you will have a predefined data type, and it reduces the data error or error in your code. It makes your code scalable. So what I'm doing, I'm creating a class. You may not create a class, you can simply create a dictionary. It is up to you. I'm creating a class which is hiring state, and I'm inheriting TypedDict, which will convert this hiring state into a structured dictionary. So it will act like a structured dictionary. Okay, I have defined the state. So now I will define my nodes. See, in the definition of the node, nothing is critical right now, because I'm not using any large language model. I'm not using any agentic tool. I'm not invoking any tool. So what is written between the definition and the return is not critical. What is important is how I'm defining what is the first line for the definition. I'm defining with the help of function, Python function. That's why def. The name of the function is receive resume, because the process that I want to replicate here is a hiring process. The workflow that we are trying to replicate in the land graph is a hiring process. Okay. So receive resume, review resume, first interview, reject the candidate, blah, blah, blah. But what I'm doing in the first line of all the nodes, I'm passing what? State. I'm passing state as an parameter. So you can see I'm passing the state, and I'm passing the name of the state, which is my class hiring state for every node, in every node. Okay. And what I'm returning state. I'm returning state. I'm returning state. This is a very critical step when you define your nodes. If you do not pass the state as a parameter and you are not returning state in a function, in the node function, then the state will never get updated for that node. So it is a critical point. So I'm running it still till this point. I'm just defining my state, defining my nodes. So nothing will happen. You won't get any output. Okay. Now this decision function is not critical. You can define it right now, or you can define whenever there is a need of a conditional edge. You only need decision function when there is a need of conditional edge. Okay. This is not important. We'll discuss about decision function later. What is critical here? So now what is critical? Now the critical is initializing your state graph object. What is a state graph class? This is the only class which create, manage, understand the workflow. It is the only class in the LangGraph library which understands the node, edges, and state. So until unless you do not initialize the object for this class, you cannot add the edges, you cannot add the nodes, you cannot compile the workflow. So what you need? You need an object for state graph. So I've created an object. The name of the object is graph. And what I'm doing, I'm passing hiring state. I'm not inheriting, I'm passing hiring state. What is hiring state? It is a structured dictionary of my state. What is the next step? Now I'm adding the nodes, but please understand where I'm adding the nodes. I'm adding the nodes to the object of the state graph through add underscore node, and there are two components to it. This is the actual implementation. This is the actual implementation of the node. This is the actual name of the node. And this is a placeholder, an identifier. You can make it like REC underscore resume. It is up to you. You can write it as A, write this one as B, write this one as C, write this one as D. It is up to you. I'm adding the nodes. I'm adding all the nodes that I created here. What is the next one? The next is I have to add the edges. So I'm adding the edges. To what? To what I'm adding the edges? I'm adding the edges to the object of the state graph. Okay. So therefore, initialization of the state graph is important. So added the nodes, I added the edges, and please understand, in this edge, I'm using the marker, the constant, which is start, which helps the state graph to understand, the LangGraph to understand that this is the entry point. This is a compulsory step. So I'm connecting my start with the next node. I'm connecting my receive resume to the review resume. But there is also a conditional edge. How you add the conditional edge? You add the conditional edge with this add underscore conditional underscore edges. What I'm adding? I'm adding two nodes. Review resume to first interview or review resume to reject. For that, I need a decision function. That is the decision function. So this decision function is created. It says if its score is greater than 7, return pass. And if it is less than 7, return fail. If it is pass, then connect the review resume to first interview. If it is fail, connect the review resume to reject interview. Okay. Now you also have to, this is not a compulsory step, but it is a recommended step that you inform your workflow, your graph, that what is the exit point. So after the interview, if you selected, you end, or you reject and then end. Perfect. Now the most important step. See, there are two steps here. One is saying compile and another is saying invoke. Just focus on compile and invoke. You cannot invoke any state graph object until and unless you have compiled it. So this is the critical step. If you run this step without compiling the graph will not invoke. It won't work. Reason being, you created the nodes, you created the edges, you created the state, you added it somewhere, but they are not talking to each other. What you need to do, you have to compile everything so they start talking to each other. That is the compilation step. So what I'm saying, the graph object that I have created, now compile it. Compile the nodes, compile the edges, compile the state in one unit. That is app. So I'm compiling it in one unit, that is app. Now after this, you can invoke your graph through the app in whichever way you want. It is simply like saying, okay, you created an object and now you can initialize that object the way you want to initialize. So now what I'm doing, I'm creating an initial state. Now this initial state could be anything. It could be like resume received is equal to true, score is equal to 8, first round passed is equal to true. It could be anything. But right now, I'm giving very initial state like false, 0, and false because we haven't received the resume. We haven't calculated the score. But it could be anything. And now I'm saying invoke the state graph object, right? I'm asking it to invoke after the compilation that I did with the help of app equal to graph.compile. Now then I'm invoking it and passing my initial state. Now see, initially the initial state was what? False, 0, and false. But when I invoke it and when the nodes will work, the edges will work, it will throw me the final result and I'm printing that final result. See, so what is happening? So in the initial state, resume received was false, score was 0, first round was false. But after the workflow got invoked and all the nodes and edges started working, the final state is resume was received, score was 8, the first round of interview was passed, that is true. You can also change your initial state. So you can see that I have changed the initial state from false 0 to false 0 and false, to true 20 and false. I'm re-invoking it. Now I'm able to invoke the state graph object again and again because I have compiled it. Compile the workflow as a unit. So you can play the unit with any initial state. So that is what is happening. So this is the complete flow of the land graph. There is very, very important thing I want to explain here. So you can also see that whether you have created your workflow correctly or not. See what's happening. So this is what the workflow we imagined. It is not that I'm creating it on my own. It is the compiled state graph code has given me this particular output. This is the image of my workflow. And if you really want to test that whatever you have implemented, whatever you have defined as nodes, edges, states, and graph, if you want to see it actually, then you just have to run this code and it will give you the workflow. If this workflow matches with your initial workflow, then your implementation of the workflow in the land graph is correct. If it doesn't, then definitely you have incorrectly added the nodes, added the edges, or initialized the state. So what is the right step to implement the workflow in the land graph? First, create a workflow on pen and paper. Then implement your nodes, edges, state, initiate your state graph, blah and blah and blah. And use this code to check whether your workflow that you have written in pen and paper is matching with this workflow. If it is matching, then the implementation is correct. Now I'll discuss about this particular cell in detail in the next session because there are a lot of components happening here. Okay. But the critical thing that you have to understand, I am not giving any information from my side to create this particular workflow. It is created with the help of the implementation I did inside the land graph. Okay. So we'll see that what are the different components of this particular cell in the next lecture. With that, thank you. Have a nice day.